So quadratic, we did quadratic equations the other day, quadratic graphs. Starts out pretty easy. It gets a little tougher towards the end, but we got a couple formulas that will help us make it easier. The first part starts about evaluating a function. When you evaluate a function, you are just plugging whatever number into that function. So like here, I plug a 2 into the function, which means I put a 2 everywhere there's an x. And then I just solve it. So 2 squared is 4. 4 times 2 is 8. Minus 6 plus 1, that would be 3. So this says when I plug in a 2, I get out a 3. This is a point on the graph, like this is the point 2, 3. That's just a different way of writing it with the function notation. But whatever's inside the parentheses, we plug in for the x's. Okay, so I believe we've done some of that before. I can't remember if we defined like relation and function and different things like that. Did we talk about domain and range? No? Okay. So let's just go over a couple words here. So you have, well, let me do this. I want to write, oh my goodness, I'm going to write intro right here just so we know it's not that problem. So a relation is any set of ordered pairs. A function is, I guess it's a relation where every x has exactly one y, okay? So that means if I say, hey, what's this x go with? There's one answer there, okay? You don't have, there's two. There's not two answers there. Every x has exactly one y. So if I ask you what 5 goes with, you only give me one answer back. I'm saying this definition here, and actually quadratics are functions. But the ones that we're going to focus on today are the domain and range. A relation is any set of ordered pairs. So the most common one that we use is x, y. Okay, like that's a set of ordered pair, right? X comes first, y comes second. The domain is the first element in a function. Okay, the first element. So most of the time, since we're talking about like x and y, most of the time this is x. Okay, we're going to deal with x because x comes first. But if I set up a function where it was your last name and your test score, that is a function because I could take your last name and then a test score. Like you took one test, right? You have one test right there. So every x goes with exactly one y. Then the domain would be your last name. So it doesn't always have to be x, but for our sake and purposes, we always use like x, y. So domain ends up being your x's. And then our last one here, the range, is the second element in this set there. So most of the time we associate with y. Back to my example of your last name and test score, like it would be the test score. So it doesn't have to be y. That's why I'm writing it as the second element. It's the second one. But we're going to talk about x and y a lot. So x is the first one, y is the second one. Okay. All right. So this topic right here says find the domain and the range. So the domain on this one is the x's, like it's the first one. So my domain, they write it as a set. It would be -2, 0, 1, and 3. Okay. My range would be the y's, 3, 5, -1, 4. And that's all you really have to do on these. These are pretty easy. This one is a function. You don't have to do this one. You don't have to say it's a function on this topic, but because every x goes to exactly one y, like -2 goes to 3, 0 goes to 5, 1 goes to -1, 3 goes to 4. If I ask you what 1 goes with, you only have one answer. For every x I ask you about, you only have one answer to go with there. So this one is a function. But like I said, you don't have to do that on that topic. Looking at the graph, maybe a little bit harder. Let me get a picture here. I want to talk a little bit about this graph before we go into actually graphing them. I just want the picture, actually. Sorry. Changed my mind to how I want to do it. Okay. On this graph, let's talk about a quadratic graph. So a quadratic graph is a parabola. It is a parabola. What they call this point right here where it changes direction is called the vertex. Okay, so that point is the vertex. It is at -2, 1. The vertex where it kind of changes direction there. What else do we have? We have what they call the axis of symmetry. You don't have to do all this for the topic. This is more just talking about the graph, but I just want to go ahead and talk about it real quick. The axis of symmetry is a vertical line that goes through it. It's always at the x part of the vertex. So the axis of symmetry is x equals -2. Okay. Because that is the point that you can fold the graph over, and you can, symmetry means it matches when you fold it over. Sorry, this sun is shining right in my eyes. So the axis of symmetry, you can fold it over at that point. It is a vertical line, so we do x equals a number, but it's always x equals whatever your axis or your x is on your vertex, okay? Because we're going to talk a lot about the vertex today. What else do I need to say? I think that's it for right now. Let's go to the domain and the range. Okay, so the domain, what you actually have to do on this problem, the domain of this, when you look at the domain of a graph, it's how far left it goes, how far left to right the graph goes, okay? How far left to right the graph goes. So the furthest point on this to the left as this graph goes is going to go forever up and forever to the left. So the domain of this one would be -infinity, and the same thing with the right. As it goes up, it's going to keep moving to the right. It's going to be infinity, okay? So the domain is your x's. Remember, it's your x's. I forgot to write that right there, but it's my x. So I'm looking left to right because that's my x-axis. My range is how far down, I know this is kind of weird to say, but how far down to up. We want the bottom of the graph to the top of the graph. Okay, so the range is dealing with my y's. So on this one, I am going to say it is the bottom of the graph. We're going to use a bracket because it's at -2, so this is interval notation. It does equal -2. I'm sorry, it does not equal -2. It equals 1, doesn't it? I'm sorry. I was looking at my x's. This is my y's. So the bottom of this graph is at 1 right here, right? The bottom of it is 1, and then it goes up forever. So it goes to infinity. So you do have to use a bracket, a 1 there. Now, one thing about this is something that will always match. This 1 is always going to match up with your vertex, okay? The vertex is either the bottom or the top of the graph, so it will always match up with something in your range. One last thing I just thought about. When you have a parabola, you talk a lot about minimum and maximum, okay? So the minimum is created when the parabola opens up, and a maximum is created when it opens down, okay? And we'll talk about how to find those in just a second, whether it's opening up or down. But you'll always have, like when your parabola opens up, you always have a bottom number and then it goes up forever. When the parabola opens down, you have a maximum number and it goes down forever. I'm going to do another one of those just because those I really like to do a negative though. Let's see if it give me a negative. There's one. All right, so here's an example of one opening down. So what we're going to learn about is you can look at the graph and you can tell a bunch of different things, but you can also look at the equation and tell a bunch of different things. So here my vertex, and again, you do not have to do all of this on this topic. I'm just prepping for everything else. My vertex is 2, 3. Okay, so that means my axis of symmetry would be at x equals 2. This graph, by just looking at the vertex, so we can tell the axis of symmetry by looking at the vertex because my vertex is 2, 3, so it's x equal 2. But you can also tell the min-max on this one. This one has a max. I don't think they do a lot of this, but I'll go ahead and write it like the max is at 2, and it is 3. It's kind of weird the way they say that, but your x, you locate it. You locate where it is, so it's on x equal 2, and the maximum value is actually at 3. Okay. So the max is actually 3, but you locate it at 2. Again, I don't think you'll see a ton of that, but just in case. All right, so now the domain and the range. The domain is my x's. On a parabola, your domain is always negative infinity to infinity because it goes forever to the left and forever to the right. As it goes up or down, it always goes to forever left and forever to the right. My range is going to have something to do with my vertex. So the bottom of this graph is at negative infinity because it goes forever down. But then the top of this graph is at 3. Okay. All right. So there's a lot of properties about the graph as we were doing that topic. Again, all you got to do on that is the domain and the range on that topic. To graph a parabola. Okay. So to graph this parabola, y equals 2x squared, a lot of times you're just going to plug in points, which is kind of annoying, but that's just the easiest way to do it. But I do want you to start associating it. So a parabola has this form, or it may have this form. We'll talk more about the second form in a second, but all I want to point out right here is that if a is a positive number, which is greater than 0, it's going to open up. And I do want you to start thinking about that every time you see one of these. If a is less than 0, it opens down. Okay. So open up, what I mean by open up is it goes that way and it goes that way. So you can just look at it and tell whether it has a minimum or maximum, and those different things by just whether it's positive. So like I said, it's kind of nice to go ahead and start thinking about that as you see these. So this one, the a equals 2, the number in front of x squared is 2, so we know it opens up. Okay. So we can kind of look at our answer and check it real quick. But the way we're going to do this really is just plug in numbers. That's the easiest way to do these. So if I just plug in, usually it wants you to plug in like 5 numbers. I'm going to talk about how to shortcut that in just a second. So if I plug in a 0, that's just 0, right? 0 squared times 2 is 0. If I plug in a -1, -1 squared is 1. 1 times 2 would be 2. If I plug in a -2, -2 squared is 4. 4 times 2 is 8. If I plug in now what happens here, I'm not going to talk about that yet. So we got 0, 0, -1, 2, 1, 2, 3, 4, 5, 6, 7, 8. We got -1, 2, and 2, 8. There is symmetry that happens on this, and I'll talk more about how to shortcut this in a second, but you always have to graph the vertex, and I don't want to talk about the vertex on this one yet. So 1 squared is 1, 1 times 2 is 2, 2 squared is 4, 4 times 2 is 8. Okay, so it's the same 2 and 8 over on this side, and that is because it's symmetric. So what you'll start to see is, if you understand it, like there is symmetry that's going on here. So really you only have to find like 3 points because you know these two are going to match up, if that makes sense. I'll talk more about that when we use it. All right, next one. Actually, let's do a negative. F of x equals negative 2x squared minus 4. So again, get in the habit of like looking at it, the number in front of x squared here, the a is negative 2. So since that's negative, it opens down. So I know my shape of this graph is going to look like this, okay? It's kind of a way to check it real quick. When we go to, again, on these, it's easier just to plug in stuff. I would almost always just plug in 0, negative 1, negative 2, 1, 2. Like, just plug in small numbers to work with. So if I plug in a 0, 0 squared is 0, 0 times negative 2 is 0, 0 minus 4 is negative 4. 1, 2, 3, 4. So I have 0, negative 4. That's not a coincidence that it's the same as a negative 4. The last number always tells you where your y-intercept is. If I plug in a negative 1 squared is 1. 1 times negative 2 is negative 2. Negative 2 minus 4 is negative 6. Y'all okay with me not writing all that down? Okay. If I plug in a negative 2 squared is 4. 4 times negative 2 is negative 8. Negative 8 minus 4 would be negative 12. So we need some extra points here. 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so we have 1, 2, 1, 2. So at negative 1, negative 6, and negative 2, negative 12. So if you use symmetry on the right-hand side, once you have one side, the right-hand side is going to be the same numbers. It's going to be negative 6 and negative 12. So basically this says as I go 1 to the left, I go 2 down. So if I go 1 to the right, I can go 2 down. As I go 2 to the left, I go 8 down. As I go 2 to the right, I would have to go 8 down as well. So that does, like, really you only have to plug in 3 points because you can use symmetry. Now, if you get to pick these points, so if you put negative 1, negative 2, and then over here you put 5 and 10, like, it's not going to be symmetric. Like, you got to have the same distance apart there on all those. But you can just plug in 3 and use symmetry. Finding the vertex axis. Okay, I gotta go find the picture of this one. We kind of already did this on our domain one, but I like to jump ahead because why not? All right, so here's kind of all the properties that we've talked about so far mentioned. I'm scared that's not going to be very big for you to see, but I'll try to make it bigger in just a second, okay? All right, does the parabola open upward or downward? This one obviously opens downward. That should be pretty easy. The axis of symmetry is going to be find the vertex. I'd find the vertex first. My vertex is at 4, negative 3. Okay? So my axis of symmetry is always going to go along with that x in the vertex. It is at x equals 4. You do have to write x equals because it is a vertical line that you're doing that. So it is, you have to write x equals 4 on that. My x-intercepts, it never crosses the x-axis, does it? So it never crosses the x-axis. It does cross my y-axis at negative 7. My y-intercept is negative 7. My x-intercept is none. Sometimes you'll get none on the x-axis. You should always get one on the y-axis. Sometimes you'll have two on the x-axis as well. Like I might do another one real quick just to show you. You need me to make that bigger for just a second? That's a little bit bigger, isn't it? So you need that for just a second. Let's go see if I can get a different variation of that one. All right, so same idea on this one. The first thing is upwards or downward. That should be easy. It opens upward. My vertex is at -4, -2. This one doesn't have the axis of symmetry, but I'm going to go ahead and write it right here. Axis of symmetry is at x equals -4. You can always just look at that number right there. My x-intercepts are at -6 and -2. And my y-intercepts are at 6, okay? So by looking at the graph, we can get all that information. We're fixing to show you algebraically how to get all that information. But all those are useful things when you're talking about stuff like it's how they measure like how far home runs are, basically using this formula because it creates a parabola. How far you throw anything, shooting rockets, you can use profit and I guess if you're losing, like when you start a company, you usually go down and then you start making profit. Like that's different things like that. All right. On this one, so this is that different form that I showed you. This is y equals x minus h squared plus k. There's something tricky here that may pop up later again in the semester. So A, we already know if it's greater than 0, it opens up. If it's less than 0, it opens down. Okay. Anytime you get a new formula, it's always nice to write down what all the variable means. H and K are my vertex. Okay. The weird thing about this is if I look at the formula, it's x minus h. So the formula starts out with a negative in front of it. So you actually do the opposite of whatever's inside the parentheses there for your vertex. Because I'm not including this negative in my formula here, or in my answer here. I only want the h, so I only want this part, okay? So x always ends up being the opposite. This is a common thing, like I said, if we do it later in the semester. Anything that's on the inside that you're looking for, or if the formula has a negative in it, you do the opposite, because we just want that h, we don't want the negative part of it. And then just to define everything in here, x and y, any point on the graph. Oh no, I lost my... Okay, so when we do this one, I'm going to rewrite it real quick. Y equals 2x minus 1 squared plus 3. So on this one, my A is 2. So that's positive, so it's going to open up. My vertex is 1, 3, okay? So that is what I mean by you do the opposite. It looks like -1, but the formula has a negative to start, so we just do 1. So you always do the opposite. When you're looking on the inside, you always do the opposite of what it says. So it's 1, 3. So with the vertex, just by looking at the vertex, I can say, okay, so my axis of symmetry is x equals 1. If this graph opens up, that means I have a minimum number. Okay? So to say what the minimum is, it's going to have a minimum, we would say, at 1 and is 3. You find it at x equal 1, and the minimum is going to be at x equal 3. So that's all the information we can get by just looking at it when it's in this form. This form's a lot easier to work with. So to graph this, what we have to do, and this is where things are a little bit different than before, is we go to 1, 3. My vertex is 1, 3. All right, so my vertex is 1, 3. We still have to do our chart, but we are going to make 1, 3 be our center point. We're making 1, 3 be our center point because that is where my vertex is. So now what you want to plug in is 2 points to the left of this and 2 points to the right of it. The instructions make you do this. 2 points to the left, 2 points to the right. So 2 points to the left could be 0, negative 1. 2 points to the right could be 2, 3. Okay, so now to plug these in. Now, again, I'm trying to make everything as easy as possible for you, but to plug these in, I'm going to plug in x equals negative 1. So 2 times negative 1 minus 1 squared plus 3 would be negative 2 squared would be 4. That'd be 8 plus 3 is 11. So that one's 11. Then I'm going to plug in 0. 2 times 0 minus 1 squared plus 3. Negative 1 squared times 2 plus 3 would be 2 times 1 plus 3. That would be 5. Okay. So if I go graph these real quick, 4, 5, 6, 7, 8, 9, 10, 11. If I go graph these real quick, I got 0, 5. So that's my y-intercept, right? 3, 4, 5. And then I got negative 1, 11. This is the left side of my graph. My axis of symmetry, what was it? X equals 1. I can just use symmetry for the other parts. So I went 1 to the left and I went to 5. I went 2 to the left and I went to 11. You only had to plug in the left and then you can use symmetry to find the right. So I go to 2, 5 and I go to 3, 11. If you get stuck, you can always plug in all 5, but you have to do 2 to the left and 2 to the right. So if you just find like 2 to the left or 2 to the right, you can use symmetry to find the other side. That's why I was talking about that earlier, because it does make these problems a lot easier. That makes you do 2 to the left and 2 to the right. I was trying to think if we want to. Do y'all want to do another one of those? You think you got it? The plugging in the points. Got it? Okay. Graph this parabola. Sorry, I want to go check to see what they tell you to do on this one to make sure. You got to do the vertex, 2 points to the left, 2 points to the right. Okay. All right. So on this one is not in vertex form where we can just look at it and get the vertex. So on this one, we have to find the vertex. And this is something that I would give you on the test. That's fine. But to find the vertex, you are going to do the opposite of b over 2a and then plug it in. Okay, you're going to do the opposite of b over 2a and then plug it in. So y equals x squared plus 2x minus 3. So here my a is 1, my b is 2, and my c is negative 3. Before I go into the vertex, I hate to do this every time because you don't have to do all this on this problem. All you have to do is graph it, but it's just nice to know. So a is 1, so that means it opens up, right, because that's positive, which means it has a minimum. Other things you can look at by just looking at it, this number right here is always your y-intercept. Because if I plug a 0 in for x, that always becomes my y-intercept. Okay. You don't have to do those things, but it's just nice to like learn everything about it right now. All right, so to do the vertex, I do the opposite of B, so that would be -2 over 2 times A. So -2 over 2 would be -1. This is my x value of the vertex. This is my x value of the vertex, which is the axis of symmetry, but that is my x value of the vertex. They are not going to plug it in right here. They're going to write some fancy formula. Whoops, sorry. My goodness. They're going to write some fancy formula. So just write, all you have to do is once you have the x, you can plug it in. So I'm going to plug in a -1 to this formula. Um, 2 times -1 minus 3. So I get 1 minus 2 minus 3. That would be y equals -4. So my vertex is -1, -4. You do have to do this on the problem to find the vertex, okay? There's a lot of important things with the vertex because now we know the axis of symmetry is x equals -1. We know our minimum. Our minimum is at -1 and is -4. Okay? So you do have to find the vertex on this. So now we go to our chart. And we say, okay, my vertex is -1, -4. So I need to plug in like a 0. Oh, wait, to the left would be a -2, -3, and a 0 and a 1. Okay. Now, like, I'd rather plug in a 0 and a 1, so I'm going to do the ones on the right this time. So to plug in I'm going to plug in x equals 0. So y, we know what that is. We already did it. 0 squared plus 2 times 0 minus 3. That's y equals -3. And then I'm going to plug in a -1. I'm sorry, a +1. Y equals 1 squared plus 2 times 1 minus 3. So 1 plus 2 minus 3 would be 0. Okay. So let's go graph these 3 points, and we'll do everything from there. -1, -4. All right, -1, -4, 0, -3, 1, 0. That's my left side. My right side should, I should get my sides right. That's my right side. My left side is going to be symmetric, so it's going to be -3 and 0. So -3, -2, -3, and -3, 0. Okay. On Alex, you don't even have to show your points. So all you have to do is think about, okay, I went 1 to the right and 1 up, so I'm going to go 1 to the left and 1 up. I went 2 to the right and 4 up, so I'm going to go 2 to the left and 4 up. And that creates the symmetry. All right, there is some refresher over from stuff the other day. Find the x-intercepts and the vertex. All right, to find the x-intercepts, you make y be 0. So if I have 0 equals x squared minus 4x plus 3, this is a factoring problem because I have an x squared and an x. So what multiplies to be 3 and adds up to be -4? Be what? -3 minus 1. So 0 equals x times x is x squared. -3 times -1 is +3. -3 plus -1 is -4. And then you set them both equal to 0. And add 3 on this one and add 1 on this one. So you get x equals 3 and x equals 1. Those are my x-intercepts. To find the vertex, I'm doing the formula, the opposite of b over 2a, and then plug it in to find the y. So write what a equals 1, b equals -4, c equals 3. So the opposite of b is -4, so I'm going to do +4 over 2 times a. That would be 2. So that is my x value of my vertex. To find the y value, I'm going to plug it in. So y equals 2 squared minus 4 times 2 plus 3. That would be 4 minus 8 plus 3 would be -1. So my vertex is 2, -1. Okay, so that's all I got to do on that one is find the vertex and the x-intercept. You kind of get used to finding the vertex because you're going to have to do it a bunch on these problems. Because like I said, the vertex is so important. It's a turning point for loss to margin. It's a turning point where the ball goes from up to down. It gives you the axis of symmetry. It gives you the minimum or maximum. All right, so on topic number 10, it says find the maximum or minimum. So if I have this formula right here, first thing is figure out if it is a maximum or a minimum. So to find that, I'm going to go ahead and write what my A, B, and C are. So my A is negative, so that means it opens down. So draw your little picture here. If it opens down, that creates a maximum. Okay, opens down, it's going to create a maximum number. So now I go do my vertex. The opposite of B is +4, so it's -4, and 2 times A. This would be -4 divided by -2 is 2. So that's my x value of the vertex. And then we need to plug in x equals 2. Be careful with your negatives here. You are going to square 2 and then you put the negative back on. You are not squaring the negative because that's not part of the x. +8 plus 1 would be 5. So my vertex is 2, 5. We have a maximum. It is at 2 and it is 5. So to find it, I go to x equal 2 and then what it actually is 5. I do want to just double check Alex real quick. It's very common to use that language, but maybe they don't make you. What is this one? Finding the maximum minimum of a quadratic function. Okay, so it just says where does it occur, which is the at, like that's where is it at, right? And what is it? So it tells you kind of what to do there. X is in there. All right, so they make it a little easier than that. But at is the location, and then is the actual what it is. All right, couple more. I think these are the last. We got like 4 left, I guess. This is just a word problem about minimum or maximum of medical equipment industry. Manufacturers x-ray machines. The unit cost is C. The cost in dollars to make each x-ray machine. Depends on the number of machines made. If X machines are made, then the unit cost is given by this function. C of X equals 0.4 X squared minus 272X plus 54806. How many machines must be made to minimize the unit cost? All right, so write down what our A is. Our A is 0.4. Our B is -272. Our C is 54806. Okay. So it says minimize, so we know we're finding the minimum, but like we can go ahead and check. This opens up, which creates a minimum number. So now we go to our vertex formula. Opposite of B over 2A, and then we plug it in to find the Y. The opposite of B. B is 272 or negative 272, so we make it positive, and then 2 times A. I'm going to need a calculator for this. 272 divided by 0.8 is 340. That is my X value. Okay, and now we are going to plug X equals 340 in. So I have C340, 0.4 times 340 squared. All right, so 340 squared times 0.4 is 46240. 272 times 340 minus 92480, and then we're going to plus 45806. So plus 46240 plus 54806. Oops. What did I get here? 8566. So this is my vertex is 340, 8566. So it says how many machines must be made to minimize the cost? Oh, you know what? We might not even need to do the Y. If we make 340 machines, it minimizes our cost to 8566. So we might only need to do the X part of that. I don't have that one pulled up, but 3X is the machines, right? The cost in dollars to make each X-ray machine depends on if X machines are made. So X is my machine. So we didn't have to do all this. My bad. Really, we just need this number right here. Because that's the machines, right? That's why you read the word problems, but that's fine. So if we make 340 machines, the cost per machine actually drops to 8566. It's one of those things like we probably need the 55,000 to just start, and then so the more machines we make, the cheaper it gets. So yeah, maybe that'll be easy on you, but that's fine. I did the whole thing. All right, here's the hardest problem in the section. I dislike this problem, so we just got to struggle through this topic and get past it. It's just one of a very common problem that you see on when you talk about maximizing and minimizing. So this is how to optimize the area. So a wire that is 48 centimeters long is shown. The wire is cut into 2 pieces, and each piece is bent and formed in the shape of a square. Suppose one square is an X, as shown below. So how can we do this? We need a variable for this other square. So let's just make that like be y. Okay, sorry, let's make this little square be y. We're bending a thing to the sides of it. So we have 4 sides, right? So I'm trying to figure out how long this square is right here, but there's going to be 4 sides that are that long because it's x. So what I'm going to do is 4x plus 4y has to equal the length of the entire side. It's just hard to set up these problems. All right. Now I'm trying to figure out what my x's are. Let's solve for y, and then we can plug in our x's. So let's subtract 4x. So I have 4y equals 48 minus 4x. Divide everything by 4, and I get y equals 12 minus x. So what this is saying is that y is going to be what is it saying? Yeah, well, okay. I'll come back to that in a second. All right. So how do we go from here? What do we know? We know the area formula, right? We know that x squared plus z squared would be my, I'm sorry, z, not z, y. X squared plus y squared, like if I did the area of the squares, that it would have to equal the total area of all of them. Okay, well, we know that these problems are, this right here, we know y equals this. So couldn't we rewrite this as x squared plus 12 minus x squared? Instead of writing y, we write 12 minus x. Now we have an equation with just y's in it, or I'm sorry, just x's in it. So let's do some simplifying here. We can FOIL this, and you get x squared plus 144 minus 24x minus x squared, plus x squared because it's negative. So you do have to FOIL that out. Combine some like terms, 2x squared minus 24x plus 144. So this is my area function. So if we want to, I didn't write down what the question says on this. Are we trying to minimize or maximize? Finding the side length, I got an example here. This one says to minimize, so we'll go with minimize. Finding the side length to minimize. So now from here, we got to do the vertex stuff. A equals 2, B equals negative 24, C equals 144. My vertex is the opposite of B over 2A. Plug it in. So I do the opposite of B, which is positive 24, over 2 times A. That would be 6. I think all we have to do is find that one. I think that's all we got to do is find that because we don't have to find what the area is. And we'll go ahead and find it just in case. So now plug that in. Sorry, I cut off the question when I copied this over. So that's 72 minus 144 plus 144. So if my side is 6 for the x, if my side is 6 for the x, it minimizes our area to 72 square feet. I'll have a conversation real quick with you about this. I don't know. I know we're out of time, but y'all are in college algebra. Like, it's almost to the point. How many people plan on going on to take more math classes, like pre-calculus or something like that? There becomes a time in math where you just can't understand 100% of everything in a class. Like, I hate to do this on this problem right here. And it usually doesn't happen in college algebra. Like, this problem is super hard. But, like, sometimes you just take a math class, you take calculus, and if you just struggle with one topic really bad, you get a B or an A or whatever, you still get an A with struggling with one topic, that's fine. And it doesn't click until you take like Calc 2. Like, that's one of the things that just happens in math. Like, it's hard to get 100% of the topics every time. So I'm saying that as in, if you don't do this topic, it's not really gonna hurt your grade at all. Try it. But I'm just telling you. Did you get it? I don't really have the question, so I'm kind of guessing at what they want us to do here based off my other example. All right. We got 3 more still? These should go fast, though. I know, this is like my longest lecture ever. All right, on this one, it is how quadratics are used to make a prediction. If you go on to take statistics, you do linear regression. This is called quadratic regression. It uses a parabola to shape it. So it says the data point shows an object speed y at a time x. Each figure has the same data points. However, each figure has a different curve fitting the data. So if we look at this one, it would be linear because there is no x squared. This one would be quadratic because it's an x squared, and this one would be quadratic, okay? But this one doesn't really match the lines, does it? Like this one goes, when you do regression, the line that you draw is the average points of the line. So this one, figure 1, should be my best fit because that's the one closest to the points. Use the equation of the best fitting curve to predict the speed at 9 seconds. So all we're doing on that is plugging that into the formula. 0.9 times 9 squared minus 3.4 times 9 plus 24. So 81 times 0.9 is 72.9. 3.4 times 9 is 30.6 plus 24. So when you set up regression equations, you can use that to predict. So if I predict the speed of the object in 9 seconds, you can do that by, this is an average of the points. This is kind of like the average of the points. So at 9 seconds, you can plug that in and figure out what the speed of it would be. We got 3 left. Oh wait, I put that in the wrong spot. We already did domain and range of a quadratic, didn't we?
Yes, sir.
Why do I got that one on here twice? Yeah, I don't need to do that one. I already did that one. The range of a quadratic function, if it does not give you the graph, find the vertex. Kind of mentioned this, but that has to do with the range. So we plug it in. I'll show you another shortcut. So here, A equals 1, B equals -2, and C equals -1. So the opposite of B is -2, is 2. 2 times 1, this would be 1. That's my x value. So now we plug in x equals 1. 1 squared minus 2 times 1 minus 1 would be 1 minus 2 minus 1 would be -2. So my vertex here is at 1, -2. All right, so let's just think about this so we don't have to draw the full graph. It opens up, right? A equals 1, so it opens up. So this is going to have a minimum. So the bottom of my graph is at my vertex. Okay, the bottom of my graph is at my vertex. So it is at -2, and then it goes up forever. So if you know, just by looking at the vertex and whether it opens up or down, you can figure out your range because your vertex is always the bottom or the top. And then the last one, I hate to not do this one because it is a refresher over what we did the other day. I'm going to do this one right here, though. To find the zeros, what find the zeros mean, that's the same thing as the x-intercept. So you make y be 0, okay? So to solve this one, we set it equal to 0. And we have to solve this. I just wanted to do this one as a refresher from Tuesday. So I do 2 times -3. What multiplies to be -6 and adds up to be 1? That would be +3, -2, right? 3 times -2 is -6. 3 minus 2 is 1. So since I have the 2 in front, I'm going to write 2x at the beginning of both of them. I write +3 and -2. 2 and 3 do not simplify. But this one I can divide by 2, so I get x minus 1. And then I have to set them both equal to 0 and solve them. This one I add 1. This one I subtract 3 and divide by 2. So those are they call them the zeros, but they are technically the x-intercepts. Okay, it's what makes the graph go to 0. So those are my x-intercepts. So you do have to just factor those when you get to that problem as well. All right.